In this tutorial, I'm going to go over how to implement my multiplayer camera, one that keeps all players on screen at the same time, into your game. And I'm also going to go over exactly how it works. If it wasn't obvious, this camera is extremely useful for things like fighting games. Similar to Super Smash Bros, where all the characters need to be on screen at the same time. But really just any game where, again, all characters need to be on screen at the same time. So in the first part of this video, I'm going to show you how to implement it for yourself. And in the second part, I'm going to try to explain how this works. It's actually a lot more complicated than I would have hoped, but it's a surprisingly hard thing to try to accomplish. But before we do either of those, just a couple of caveats. So one, this camera only, I mean, I guess it would work in 3 dimensions, but really it's fine-tuned for just 2 dimensions. So everything should be on the same plane. In this example, everything has a Z coordinate of 0. So everything is like flat up against the background. You can see how when I grab something and then release, it snaps into place. That's pretty important. It would be way harder to tune this camera properly if the players, the cubes, could be anywhere in 3D space. That's another caveat, by the way. This camera needs to be like fine-tuned. I've already done that, but it doesn't sense if things are out, if things are off screen. It's just tuned in a way where it zooms out properly. And the final caveat, it's currently only working in this direction. So let's say you wanted a top-down game. Maybe you're making a mini golf type game and you want all the balls to be in camera at the same time. That would be top-down, obviously. And I'm pretty sure this isn't going to work if I just rotate the entire thing. You'd have to change some stuff, which is annoying, but totally possible. Just keep that in mind. It's currently only working for side view games. So with that out of the way, let me go over kind of like how it works, like what is actually happening, and how to actually put this in your game. It's very, very easy to implement. So what's the goal with this? What is this? This is a camera that can keep that keeps all the players in view at the same time, no matter where they are. So if we have 2 players down here, one way over here, the camera will go to basically the average position. It doesn't, but I'll get to that. And it zooms out so all the players fit. But then if this player over here goes towards these guys, we zoom in, all right? So all the players can be anywhere with this camera, and it will move and zoom out or in to fit everything. This was not easy. There were a lot of catches. There were a lot of things that went wrong. But I'm very happy with how it turned out. So with that, let's get into how to actually like use this. It's really, really simple, fortunately. So we're in a new scene. I'm assuming this would be your game scene where you have your players and you need a camera. We're gonna go to search, and we can just search for multiplayer camera. All right. And I just made this. Hopefully it has more likes by the time you use it. But here it is, multiplayer camera kit. We take it, we put it in, and you can see it's already working, which would be weird if it wasn't working. So see. Now the only other thing to do is, is to make it work for your players. So obviously your players aren't going to be the cubes that it comes with. Now, I didn't set up like a demo with players and stuff, but let me show you what you need to do. Literally, all you need to do is take this, really just this, and put it on your player. All this camera needs is a position. That's all it needs. All this other stuff is just for the demo, basically. It's really important. Again, so this code, this logic, keeps it on the same plane, keeps it to 0, right? See? So you can use this if you want, but you probably just want to make your game already do that somehow. So just keep that in mind. But again, all the character needs is a position. So you would take the position and wire it into one of these 4 nodes. This does not need to have all 4 players. I've programmed it in a way where the logic deletes itself. All right. But let's say you wanted the 4th player. Bam, 4th player added. That's all you need to do. Wire in a position right here. So now when we play, this 4th player is working. It's the camera is taking it into account. It is literally that easy. Here's another cool thing. What if during the game 2 players or like the players are destroyed and they maybe they die and you need to wait until the end of the round. So we're playing, right? Let's pause and let's scope in this time and delete this player, and how about this player? So you see we deleted player 1 and player 4. Now when we unpause, the logic gets destroyed and the camera readjusts. So now the camera is only taking into account 2 of the players. Another caveat, you cannot re-add players without basically respawning the camera. You'd have to reset the entire scene, which is hopefully fine for most things. But once you delete a player, you cannot add it back because of the way the logic deletes itself. One last thing that you need to know when setting this up is these 4 sliders. All right. This is how you tweak it. I've already tweaked it. All right. Like all the settings are already good, but if you want to change some stuff for whatever reason, let me just explain what these do really quick. So there's zoom X multiplier and zoom Y multiplier. Basically what this is, so on the X axis, so basically left and right, based on how far apart the farthest left player is and the farthest right player is, that zooms the camera out. And this multiplier is how strong that zoom is. So, I mean, right now, it looks like this. Let's just put everything in a line. Okay, it looks like this. If I increase it to maybe 1, notice how it zooms out more. All right. But if we put everything in a line, and now we decrease it back to 0.5, it looks exactly the same because it only affects the left and right zoom, if that makes sense. Same for zoom Y. So if we, everything's in a line, right? And we put it up, it's gonna zoom out. But it's only based on the Y coordinates. I mean, one thing I'd like to address, notice how these aren't perfectly centered. So that is something you could change. I personally figure that these cubes are like the bottom of the character. So you'd want, and I've actually angled the camera down a little bit. So I don't know, I've tweaked it thinking that like you kind of want, you kind of want the characters to be sort of towards the bottom, but you can change that. So with Y offset, it's 2.8. Now these numbers don't really make sense. This number makes sense. If we put it to 0, it's gonna center them, right? Well, okay, maybe not perfectly. Oh, it would be centered, but again, the camera is angled downward, so which is why you have the Y offset to tweak. So that is literally just how it's the offset of the Y of the camera. That it's as straightforward as that. And I think I had it at 2.8. Maybe we put it to 2.5. I don't know. And then finally, the zoom, or did I say zoom offset? It's the Y offset. And then finally, the zoom offset. This is basically the default zoom. So if we put it to 0, right, it's going to be really, really close. It's kind of like the default zoom. Maybe that's what I should call it. So like no matter how close we make these, it's defaulted to this zoom. So like if we make that bigger, it zooms out. And if we make it smaller, it's going to zoom in. Now, okay, obviously with the Y offset, it's a little off. So maybe we want, in this case, yeah, so fixing the Y offset. Again, they're not perfectly centered still because, again, the camera is angled downward, but I think you get the point. So, and notice how it still kind of works. I mean, it's not kind of, it works perfectly. The only reason it's a little off camera is because of the camera tilt, but yeah, so hopefully that kind of makes sense as to what these sliders do, so you're not just like randomly changing things, although I mean eventually you'd be able to figure it out if you randomly change things. But yeah, that's it. That's how you implement the camera. If you have any questions at all, check out my Discord. It's the best place to ask, and I will personally help you out. I'll go as far as to collab into your game to get this working. Hopefully I don't need to do that, but I will. So now the fun part, the super fun part, let's get into how this works. So there are two main things. The player and the camera. There's nothing else. So I guess not two main things, there are just two things. Let's start with the player first because that is by far the easiest. We have, this is just debug stuff. This allows me to grab the player with the imp. So basically when it's grabbed, it's movable, and when it's not grabbed, it's not movable. And then this is okay. So Origin Z, this is, we have a, oh, I don't even think I added this to the scene, but basically this is just 0. This is the number 0. Okay, that's all you really need to know. And we are following to 0. X and Y are not affected. Z strength is. All this does is snap the player to 0. You shouldn't need this. In your game, the player should already be constrained to that axis. You shouldn't need something like this. It depends. Okay, it just completely depends, but maybe you do. It's okay. But yeah, that's what this does. And then this is just the position, right? We're taking the scene space transform and splitting the position, and we're using that. The camera's using that. That's what's in the player, guys. It's really, there's nothing else. Okay, cool. So now for the camera. But before we dive into the camera logic, I just want to explain like what I'm trying to accomplish. So there's two things. Position. Well, okay, it's all position, but there's two main considerations. Left, right, up, and down is one. And then forward and backwards, which is essentially the zoom. Let's talk about the position first. With the position, we can break that down further into left or right and up and down. My first solution, which was pretty naive and didn't work, was to literally just take the average position. Just completely take the average position. But what went wrong with that is if 3 players are like really close together here, and then we have another player out here, it would be prioritizing these 3 players because, I mean, there's 3 of them over there, right? So the average position would be like here, where my imp is. What I've done instead is I've broken up the position into X and Y. With the X position, I don't care how many players are over here. All I care about is the greatest X position and the smallest, the most negative, the farthest to the left X position. Farthest to the right, farthest to the left. The X position of the camera is in between that. Same for Y. Farthest up, lowest. So highest Y, lowest Y, and the Y position of the camera is in between that. It is just the average of those two. taking the average position, which was easy to do, did not work because again, it was prioritizing like the group, which is not what you want. And when you combine the average X and the average Y, it's not even, you know what I mean? I don't know how to put it. It's not the average X and the average Y. It's the average of the most extreme X and the greatest X and the smallest X, and then the greatest Y and the smallest Y. Combining those two things gets exactly what we want. It gets exactly what we want. It's the center, right? It's a position where all the characters are in the camera. And now the zoom, the Z direction, the in or out. This just took a lot of tweaking, but basically I found the greatest distance. So I check the distance between every single player, take the greatest one, do some weird math on it, and then set that as the Z. The Z being how close or far away it is. That's less clever. I mean, that it was just basically trial and error, but it's just how it's the greatest distance. So yeah, that's how zoom works. It has nothing to do with if it's on screen or not. I'm not sensing. I could sense it, but it's not. It was just trial and error. All right, I think we're ready to get into the camera logic. So good luck. Here it is. Here is the chip. This logic right here is trying to figure out the position, like this. These 7 chips. That's what they do. This is the camera. This is the follower. These are the action recorders for the demo, and here are the sliders that tweak the different values that you can tweak. And then, and here is where the Z location is, because again, this is for 2D, right? So right now, I don't even think this isn't even in the scene. It's not in the kit, which it should be. So it will be by when you're seeing this video. But yeah, this is where basically the wall, the background is. It might be, let's just follow the position, the logic. So we have a position coming in from the players, and it goes through this node. This node passes it into this chip. This chip, I mean, this is super simple. Basically, we're just taking in the position, and we're also taking in whether or not the wire's connected. If there is no wire connected into this, it destroys this entire chip, which will affect these chips here. But just know that if there's no wire into this, this is destroyed. But what are we doing with the position? We're splitting it into X and Y. A is X, B is Y, C is Z, if you didn't know. And we're outputting X and Y, and then we're also outputting the entire position. All right, so what are we doing with this? We have this chip, which figures out the zoom, the Z position for the camera. This calculates the X, and this is the Y. Let's save zoom for last and go into the X. So the basic idea is relatively simple. We're taking in the X, right, of each player, and if it's not connected, well, let's cover that later. So what are all these chips? Each the idea is we're comparing the distance between between each one of these, and we're getting the greatest. We're finding whichever one is the greatest. So like, for example, this chip compares player 1 and player 2. This chip compares player 1 and player 3. This one is player 1 and player 4. This one is player 2 and player 3, etc. You get the point, hopefully. So, for example, let's say player 2 dies. If this wire is not connected, if there's nothing going into this node, this NOT gate turns on, which triggers a destroyer in this one, and this one. So basically, actually, in this one, and this one. I know it's messy, like it's hard to follow these wires. I don't know what to tell you though. I mean, I guess I could use wire nose to neat it up, but that's not the point of this video. Anyway, so basically, if a player gets destroyed, every chip that's related to it also gets destroyed in this. So what's actually going on in this chip? Again, we're calculating the distance, right? So how do you do that? I mean, you literally just subtract. You take this X and subtract it from this X, and then take the absolute value. Here's the destroyer we talked about. And then, but great, we found the distance. What do we actually want though? We want the average. We want the average position. We want the, not the average position, sorry. So we have two X's, right? Two X coordinates. We want the number in between that, which is the average. But so we want to get the center of that. And to do that, you add them both up and divide by 2. Or you take a node, you put both wires into it, and you blend it with the little zero thing, which takes the average. So yeah. How do we know it's the greatest, right? So we want to find with the subtraction, we want the biggest number, right? So let's say X is 20 and then the other X is -2. Which is 22. The difference is 22. And let's say that's the greatest. Let's say that's the greatest one. I'm using exclusive gates. So I'm putting the absolute value of the distance and I'm putting it into the priority. We have a constant on signal going into the gates, the exclusive gates input. And if this exclusive gate turns on, let's just play and pause. So this is a bad example. This is a really bad example. Hold on, give me a second. We're gonna move this over just a little bit. Okay, and pause. So this, whatever this one is, the X, and this X is going to be the greatest. So this one is 3, and this one is player 1. So player 1 and player 3 is going to be the one that's on right here. See, player 1, the X is going in. Player 3, the X is going in, and you can see this is the value that gets chosen. Why? Again, we have the distance going into the priority, and it's the highest priority, so this gate is open. This gate being open allows this not signal to power on the node, which allows the average of player 1's X and player 3's X to be passed through. Okay, and then there's the value. We take that value, we take the average position. We take the average of the two X values. We add nothing, apparently. We take that average value of the two X positions and we output it. And that is our X position of the camera. So that's what it is. It's just the farthest two X points and the average between the point between both of those. All right, and Y. Let's do the Y coordinate next. Same exact thing. Same exact thing. The only difference is that we have this calculator here, and we're just adding a flat offset. All right, and that is connected to this slider. So it's literally just adding. The reason is because I have the camera angled down a little bit. You do not have to do this, but I did. If you want to undo it, just angle the camera back up and then change the offset to probably 0, honestly. But yeah, that's the only difference is this offset. All right, and now the zoom. Relatively similar idea. You can see how it's kind of the same setup, except a little bit more complicated. As I said earlier, we're using the farthest distance, the largest distance between any two players, and we're just using that number and arbitrarily doing a couple things to it, and then just that's what the Z value is. Let's ignore this. All you need to know right now is that these are the positions. All right, they're not, but let's just pretend they are. So these are the positions of the 4 players. Same thing, guys. We're just comparing. These calculate the distance, and we're just finding the distance between every combination of players. So player 1 and player 2, player 1 and player 3, player 1 and player 4, player 2 and player 3, etc. The difference is we're actually using that distance number. Well, there's two differences. The first difference, not distance. The first difference is we're actually finding the distance. It's not like of two coordinates. These aren't just single values, like X values or Y values. This is the entire coordinate. But this is the entire position. So notice how they're fat wires. If you didn't know, the way to find distance between two fat wires, two vectors, two positions, is to subtract them. You just straight up subtract them. But to actually get the value, you have to convert it into a skinny wire by passing it through a slider. So that's what I'm doing here. I'm turning this distance into a skinny wire, not a fat wire, taking the absolute value, probably not needed, but whatever. And maybe it's needed. And outputting that, that's all. We don't need the center, right? We don't need the center. I don't care about that. All I care about is the magnitude. All I care is like how far it actually is. And again, we're finding the largest value. The reason we don't need exclusive gates is because we actually want that value. That is the value we want. So we're putting all these distance values into a node, and we're using this blend type, not the blend, but the overwrite. So what this does is literally just take the largest value, which is exactly what we want. So we've successfully found the largest distance between any two players. What are we doing with that? Two things, clearly, two things. First thing is the origin. So we're taking that value, we're taking that Z value, and we are adding whatever like the origin Z is. So let's say, when I say the origin of Z, it's basically your wall, your backboard, your background. I'm trying to move all of it. So let's say we move all of it here, right? Our origin, our backboard is no longer on 0, which is the center right here. It would be here, which is like 5. So this input just allows you to change that if you want. Probably best to keep it at 0 just for simplicity, but yeah. Okay, and then what's the second thing? It's actually a combination of two things. Oh, well, it was. At one point I was multiplying this by something, but I just changed it to 1, so I guess I'm not doing that anymore. But it's another just flat offset. So this was the origin, the Z offset. This is literally just a zoom offset, whatever you set. It's just a flat number, and it's just your default, your base zoom. Obviously, if you set it to 0, the camera is gonna it's gonna be a little too close. I mean, it's actually pretty decent, but you probably don't want your players, like if your players are on the edge, you probably don't, you want to give them some buffer space, right? And this is what allows that. This is what allows you to add that. And then, so after that, we have our value. We have our Z value, and we put it into the combiner. So we've successfully gotten our Z coordinate, X coordinate, and Y coordinate. What do we do now? We basically just put it into a follower, but there's one more thing. Well, let me show you what happens when you don't use a signal manipulator to basically smooth the position. You can see how it's very rigid, which maybe that's what you want, I don't know. But with this signal manipulator basically smoothing the output, it makes it a little bit smoother, go figure. So yeah, I mean, we take the position, we smooth it by 0.5 seconds. Maybe you want that lower, maybe you want that higher. And we put it into a follower. That is 100% on everything, 50 movement speed, 100, 100. I mean, you can tweak this if you want, but yeah, and then that changes. That's what sets the position of the camera. And that's it, guys. You made it. Let me know if you made it, made it through that explanation in the comments. I hope you guys enjoyed this tutorial. I really, really hope you're able to actually implement this in your own games. If you are, please let me know. I love seeing you guys use I love seeing my stuff being used and implemented. It's pretty awesome. Show me your implementations in my Discord. But yeah, and if you have any questions, don't hesitate to ask them. I highly recommend you ask them in my Discord. But yeah, that's it for now, guys. I hope you enjoyed the video, and I will see you in the next one.